The great systems within the metric, or the reasons why the metric system is so great, is that whole powers of 10 shift. Okay, that can make our conversion factors very easy. If we don't want to set up the whole dimensional analysis thing, we can do decimal point shifts. Okay? And that's great. You have multiple ways to go through and solve those in ways that your brain goes, I know how to do this, so you can check all of your work. Okay? Well, here's the first case where dimensional analysis comes in, because we can't just use our brain just to do a quick check on it. We have to do some actual calculations, and that's where dimensional analysis comes in. Okay? So when we shift between English and metric, we have to be careful with our conversion factors. Notice for length, the English unit is inches, the metric equivalent, centimeters. That's not a power of 10, it's 2.54. Okay? Mass, pounds to grams. Okay? 454 grams. So these aren't simple conversions. Okay? They aren't simple things that we can kind of just jump across on. So we need to evaluate these a little bit more carefully, and we'll use those in our dimensional analysis to go through and set up conversions, okay, in order to come up with numerical answers. Okay? One of the things that we will have to be cognizant of, which will become more important when we move into the question, is we also have to be aware of our sig figs. Okay? When we run a calculation, we can't increase the amount of significant digits, we can't decrease it, we must maintain based off the measurement that we had. Okay? So if we look at our conversion factors, within the metric system it was great, because we had infinite sig figs. It was powers of 10. These were exact things. Okay? But if we take a look at our numbers here, these aren't powers of 10. So how many sig figs do we have in these conversion factors? Okay? And for the sake of argument, let's take a look at those two. How many sig figs do we have in there? Okay, 3. This gets a bit weird, because really the textbook should have written it slightly differently. It should have been written as 1.00 pounds, 1.00 quarts, so that we had 3 sig figs in those conversions. Okay? Really the textbook is making the horrible assumption that by writing 1 we're saying it's exactly 1 equals 454 grams. You might say, well, that's an exact conversion. No, it's not. Okay? What happens if I want 4 sig figs?
There's 1 sig fig in the inch. So
I don't want to look at inches yet, unfortunately. But we could shift to pounds. Okay. Well, there's 3 sig figs in pounds to grams, right? What if I want 4?
Add another 0.
Okay. I can't add another 0, because it's not 0. Okay, the 1.00, that one's okay, so I can get that 0, but then how do I get more sig figs on the grams? Dot, it's not 0 though. It's a different number. How would I figure out what that number is? I'd have to go look it up. So if I want 4 sig figs, I have to look up a new conversion factor. Okay? The first 3 of them will be 454, right? But I need a new sig fig. What if I want 5 sig figs or 6 sig figs? I have to keep looking up new conversion factors. Why do I need new conversion factors? Well, if I want 5 sig figs and my conversion factor only has 3, what happens with my answer? It drops to 3. So it's not that it's wrong, it's that my answer drops to 3 sig figs. Dependent on what? On the conversion factor, not the measurement. Okay, well, if that's the case, don't use such an accurate measurement device. Okay, the measurement device should dictate the amount of sig figs that we run, even if we have to go through conversions. Does that make sense? Okay. The reason why I box those 2 in and not the top one. Okay. And for those of you that read really fast, maybe you saw that there was a footnote. And maybe you were able to read that footnote. Did anybody read that footnote? Don't cheat and look at your notes. That's not fair. Nobody read it. Good, because I erased it fast enough. Guess what the footnote says about the inch to centimeter? The inch to centimeter is exact. That is a definition. 1 inch is now defined to be 2.54 centimeters, which means the number of sig figs in that first one is infinite. The next one's 3. The next one's 3. The last one, it's the same unit, so who cares? Right? It's really nice of them to say 1 sec equals 1.00 s. Just pick a unit, guys, and stick with it. Okay? Our inch to centimeter is a definition. It is infinite sig figs. Okay? Why is it infinite? The measurement, the length measurement, is something that we've done often enough on having to convert between different systems that we said, this is silly. We should just have one unit to describe it. Well, no, I'm not going to change. Okay, well then we're going to agree to disagree and make absolutely certain that this is now the definition. Now it has simplified our calculations when we look at our length measurements. Why would we care about length measurements more than mass or volume? When you build something, what do you typically measure? You're typically looking at length measurements. Okay? So a lot of our measurement systems for building between nations has to deal with length, so we tried to standardize that measurement. Okay?
But infinite, to me, seems like it would be like, there would be several different possible measurements, but if that's the definition of 2.54, then...
That is the definition.
Then it doesn't seem like it could be infinite to me, so I'm a little confused on the infinite.
So we can come back and talk about that after class. The infinite just means that when you use that conversion factor, it does not dictate your answers.
Okay.
Okay? And that's the biggest deal. When we're looking at our conversions, the conversion factor should not dictate the sig figs in your answer.
Is that kind of like pi?
If it does, that's a problem. Not like pi. Sorry. Pi is a whole nother 8-ball, if you will. All right, so let's take a look at the conversion or the question below. Okay, so and we're going to erase all that now. Okay, so there's our footnote. 1 inch is exactly 2.54 centimeters. That's our now definition, which means that conversion factor has infinite sig figs. Okay, so let's take a look at some practice on setting up our dimensional analysis. Okay, the length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? Okay, so I'll set this up with the basics on this for our work. Okay, step 1, we need to write what we want. We want centimeters on the far right. Step 2, what are we starting with? Yards. And I just so happen to start with 120 yards. Okay? Is yards the same thing as centimeters? Nope. So I need to multiply by a conversion factor. The ideal situation would be yards needs to be on the denominator so that it can cancel with the yards in the numerator from my 120. Right? And ideally, what would I be converting to?
Centimeters.
Centimeters. Does anybody know the yard to centimeter conversion?
No.
No. Okay, which means the ideal system didn't work for us. I'm going to have to convert to something else. Okay? What is that something else? That is your call. You need centimeters, you need yards. You could erase the yards and convert centimeters to something else. Okay? Or you could erase the centimeters and convert the yards to something else. That is entirely up to you. Because we're doing multiplication and division, the order doesn't matter. I make the argument that it is easier to get rid of the yards to convert to something else than it is to do centimeters to something else. But that is my preference. Okay? So that is all the work I'm going to give you. Your turn. Talk to the people around you, see what you guys can come up with. I will be coming around to see what you have, and hopefully we'll get a couple answers. It has lots of fun little kind of, I wouldn't call them Easter eggs because they aren't pleasant surprises, but they're little surprises embedded in this. So the first thing I want to address is I got a lot of people saying, well, yeah, I may not know the centimeter yards, but I know I can look that up. Right? On a homework, by all means, go ahead and do that. The problem with doing that, though, is that you're shortchanging yourself, because when you get to the exam, you can't look up that conversion. Okay? You need to be establishing a process that allows you to move through based off the information given. Okay? And yeah, it's a good idea. Check the front of the exam. Maybe I do give you the centimeter to yard conversion. I won't. Okay? So you need to use the information given, and in theory, there might be some other ones in there that you might remember that you need. Okay? But I think all of the conversions are necessary that are necessary for this calculation are up on the board. Okay? And as I went around and did this, or checked people's work, okay, I think the answer that most people settled on would have been 10972. How many people agree? That's what your calculator spat out. Okay, everybody's saying yeah, yeah. Okay, so let's take a look at this. Let's go ahead and take a look. I'm going to say, well, yards, I got to get to centimeters. I know my core unit for centimeters is meters. And if I look, oh yeah, here we go. Yards, meters. There we go. So I'm going to do yards to meters. Okay. Which then means the yards cancel. By the way, I will need someone with a calculator to help me out on this. So meters, I want to get centimeters. Well, centi meant, centi means 10 to the minus 2. My power of 10 is always associated with the core unit. I know where you're going with base, but I prefer core unit, which is a recent development. Okay, so there's my 10 powers 2. I even started to put in numbers a bit premature, right? Oh, centimeters, I would have my answer. I just need to bring in my numbers. 0.914, so 0.914, then 1, and now it'd be good to calculate, right? 109.68. Am I right? No, what happened?
Just 0.914 with the meters.
0.914. I don't just divide randomly. I don't place those numbers randomly. Where's the 0.914 in front of in my conversion factor?
Meters.
In front of meters. Where did I write it? Not in front of meters. Okay? And you're like, oh, that was dumb. No one would make that mistake. You do. You make it all the time. It's okay. That's why you need to pause and say, okay, I don't want to just randomly put the number in. I want to make sure it's tied exactly as this. Okay, meters has 0.914 in front of it, so 0.914. And just for giggles, let's go ahead and talk about something else. 0.914, 1, right? And now I can enter in the calculator. I have 120 times 914 divided by 100. Whoa, what? What do you mean, what? Isn't that what that says?
No. You're missing a dot.
Oh, dude, I did have a decimal there. If I'd put the leading 0 there, maybe I would have been like, oh, that's not 914. Why would I put a 0? Oh, yeah, I had a decimal. Yeah. See, thinking back. Okay. Punch it into the calculator. My calculator, being awesome, will tell me exactly the same answer that you all looked up. And we get, for an answer, 968, like 0.4? No? Okay, let's just ignore that then.
That's it.
Oh, that's all it tells you. Okay, well, there you go. Centimeters.
109 point.
You just told me the answer was 10972. I just did the work, and it's 10968.
There's a discrepancy somewhere.
Where's the discrepancy between those two numbers? In the conversion factor. Yeah, isn't that awesome? Okay. We may have defined 1 inch as 2.54 centimeters, but this 0.914 meters is 1 yard is not a definition. Okay. Which then means this conversion factor is slightly different than the 2.54. That slight difference gets us 2 answers coming out of the calculator at the end. Ouch. Okay. This is why we have to be very careful when we do conversions between English and metric. Depending on how we set up our conversions, we may start to drift in our answers. Okay. So you have to be aware of that. Just keep it in the back of your head. Okay? Which then brings up the question that you might be asking, well, which answer is correct? Well, you're wrong.
They're both wrong.
So am I. Both these answers are wrong. We can't add them together to get the average. Unfortunately, we're adding another calculation into that, which would mess it up. It all comes back to our favorite significant figures. How many sig figs in 10.968? 5. How many sig figs in 10.972.8? 6. Okay. Number one, they have different sig figs. That's really weird. Okay. We have to go back to our calculation. In that last conversion, centimeters to meters, how many sig figs?
3. No, infinite.
Infinite. It's a definition. Meters to yards?
3.
3, coming from our 0.914. Yes, the 1 should be written out as 1.00. Okay. 120 yards? 2. Why are there only 2 sig figs at 120 yards? The 0 is only a placeholder because I don't have a decimal point. Which means when I go back and take a look at my answer in purple, I can only have 2 sig figs. But that next number is larger than 5, so what do I have to do? Add 1. And I could get 11,000 centimeters. How about your answer?
Yeah, but wouldn't that be estimating it, and that wouldn't be exactly what it is, though?
No, we'll come back to that in a second. 11,000 centimeters.
So now we're not looking for an exact number.
Okay. So, and this is something that students like to fight on. Well, isn't this now an estimate, not exact? 120 yards is only as accurate as those 2 sig figs. We're starting with an estimate. Okay? You can't tell me that, well, it says 120 yards, so now I'm all of a sudden, because I do the calculation, I'm doing an estimate. No, you started with an estimate only accurate to 2 places, which means your answer can only be accurate to 2 places. Period. Okay? We aren't used to that because when we take measurements out in the real world, we don't see 120 yards as 2 sig figs. We see it as 3 or 4 or infinite. All of that is dependent on the measurement, on the device you're using to make that measurement. In this case, I'm only accurate to the tens place. Okay? I only have 2 sig figs in that measurement, which means when I get to my answer, I can only be accurate to 2 sig figs. Okay? Just because we're given a number doesn't mean it's magically this great, awesome, exact value. That's not true at all. That given number is only as precise as the digits specified within it. That means our answer has to be reported accordingly. Okay? For those of you that have started the practice exam, this question was straight off the practice exam. Okay? And there were 3 answers on there that you should be like, what the F? 10,968, 10,972, and 11,000. All 3 of those numbers showed up. If you did this question correctly, you get all 3 possible answers. How do you decide which one's correct?
The one with the sig figs, correct?
Okay. You'll have to evaluate the sig figs. When you look at that multiple choice, if you're given all those are only different largely based off of sig figs. The question is asking about sig figs. Why can I now dump this into the exam, okay, and still test at the conversion? It's show your work. So I can still ask questions about, do you understand how to convert, and ask a sig fig question at the same time. Okay? Only because it's a show your work question. Does that make sense? Okay. The work that I saw around the classroom for 10.972.8 was perfectly fine. I didn't see anything wrong there. Do you need me to go through and show that other conversion factor?
Sure, yes.
Okay. We got enough yeses. Sorry for those people shaking your head no. There were more yeses than there were no's. So 120 yards. Okay. Again, I did that process wrong because I started with the yards. Trying to get to centimeters. Yards, you guys said feet. Turns out there's 3 feet in 1 yard. The yards would cancel. want to get rid of feet. Ideally, I'd go to centimeters. I don't have that. So I'll go to inches. My feet would cancel. I don't want inches, I want centimeters. Yep, I have that conversion. The conversion factor I have is 2.54 centimeters is 1 inch. The conversion factor between inches and feet, 12 inches is 1 foot. Where does the 12 go? With the inches. Someone has heard me yell and rant about that too much. Okay. And I now have my conversion factor to run the whole thing. Makes sense? Yeah.
Yes.
Okay.
Do you have another 120 over 1?
So a lot of people will ask about this on what's in the denominator here, because I am establishing this as fractions pretty much all the way through. And you will oftentimes, when you look at dimensional analysis, will almost always see your starting value, whatever you were given, is written just in the numerator. It may not have to be. Okay? So it can help if you want to make sure it's extra clear that it's in the numerator, you can do so. Okay? Does the order of where any of those conversion factors gets written matter? No.
Well, why would you write centimeters before inches or feet before centimeters?
Okay.
Or centimeters?
Why would I start shuffling those conversion factors? It depends on what I see as the person solving this. When I walked through, I said, well, I'm starting with yards. I'm going to get rid of yards. What if I started this whole question off and said I wanted centimeters? Well, the very first thing I'm going to have written here is centimeters. Centimeters doesn't convert to yards, so I'm going to convert centimeters into something else. What is that something else? Anything I want.
It just illustrates the thought process.
Okay. I want centimeters in the numerator. Okay, well, centimeters, numerator, what can I convert centimeters to? Definitely can't go yards. Yeah, I got inches. Let's go ahead and try that. Let's try inches.
Not yards?
2.54 centimeters. It's 1 inch. We don't have the yard conversion for centimeters to yards, so that doesn't work. Okay. So the issue with this format is now what happened to my units.
They're weird.
It's really weird. I've actually got more complex units than if I started the other way around.
Yeah, that's not right.
It doesn't affect anything. Inches I want to get rid of.
Confuse yourself.
And so that's where it comes in. What do you, as an individual, see? If you see, I want centimeters, then you start here. If you say, I don't want yards, then you start with what was previously shown. Either method works perfectly. And this is something that becomes challenging for students. You sit down with tutor A, they go through and solve something. Like, okay, I think I get it. You sit down with tutor B, and they show you an entirely new way, because they saw a different sequence of those conversion factors. Whichever one clicks for you is the one that you've got to use. Okay? So I've shown two processes. Okay? Starting getting rid of yards or coming in with centimeters. Okay? Do we want to do another conversion? Okay. We heard a no, so I will agree we won't do this conversion. Okay? You've seen these kind of questions before, right? Like in math classes. Harry wants to exchange his things. Okay? Harry's taller than Sally. Sally's shorter than Timmy. Timmy's taller than Jerry. What's Jerry's height with regards to Sally? What the heck kind of a question is that? Just put them in a line. I see them. That one's taller than that one. This is dumb. Okay? Where are these questions coming from?
Perplexers?
People with
These questions are coming from real-world examples
What?
with different bizarre units that we don't comprehend. When you set up that conversion with those, you're like, that's stupid. Anybody could do that. Okay? We aren't giving you this question to make you go, oh, I know how to solve this now. We're giving you this question so that you can build a process that allows you to say, I can do this. And this is how I do this. So that when some jerk-off comes in and switches those things to weird units of Snorlaxes and Skittle farts, you may not comprehend what's going on with those. But you have a process. That process allows you to read the question and go through and say, well, this is where this conversion goes, this is where this conversion goes. All right? So for instance, if we now had to solve this one, okay? Harry has Snorlaxy and he wants Skittle farts.
It sounds like a disease.
So what I meant, that's a new one. I want Skittle farts and I start with Snorlaxy. Right? The Snorlaxy I've got 100 of them. Well, those units don't match up. I need to get rid of Snorlaxy. Okay? Snorlaxy need to be converted to something. I can look through. Snorlaxy as a conversion factor only shows up once with dimes. According to my conversion factor, what is that? 8 dimes, 10 Snorlaxy. Now I have dimes. Well, dimes aren't very useful. Because dimes are not Skittle farts.
Well, 3 dimes.
Believe it or not, this is the most straight-faced I've ever done this example. I'm actually impressed with myself. Okay. Or I need to come up with goofier terms. Right? Dimes to Skittle farts. Do I have that? Oh, 3 dimes is 1 Skittle fart. Dimes cancel. Do I have to have any understanding of what the hell a Skittle fart is or a Snorlaxy? No. Completely irrelevant. I can still solve the question. The process gets you there. Right? And understanding of those units can come later. But we need a process to make sure that we can make it through. Once we have the process, we can trust a process to convert bizarre units that we can then later say, well, what does that unit mean? What does that mean? Okay? The meaning takes a lot longer to process and understand. Okay? So get the process down, the meaning will come later. Make sense? Okay? Unless it's this question, in which case I don't think you will ever figure out what a Skittle fart is or a Snorlaxy is.
No, but with this process that you had up there, can you have can you leave it in a fraction form, or does it have to be a whole number? Because it turned out that it was like
You
8
could-
over 30.
So if you looked at that, that would then be interpreting your numbers as a later effect. And yes, you're right. Then we'd have an extra thing, because there is a decimal or a fraction value to that. And that's going to come down to, what are you trying to do? In this question here, right, we're looking at solid physical objects. Can I have a fractional of a solid physical object? No. So I'd end up losing the decimal value and just use the whole number. It depends on what you're working with.
But how would you get a whole number from that number?
Did anybody actually calculate it?
2 2/3.
2.666, right? So on. What are we, Skittle farts?
Yeah.
Devils.
Right? I can't have 0.66666 Skittle farts.
So it
Doesn't happen.
transfer to 3.
So in this question, what does it become?
2 Skittle farts, 2 dimes.
2 Skittle farts. I can only achieve that. I can't get to 3. 3 would be rounding. Okay? It comes down to the whole numbers. We'd have to evaluate what that number is representing and what the meaning of a Skittle fart is. If that is a physical object,
Right.
I can't get 2/3 of that. I can't round up and all of a sudden have 3. I didn't have enough pennies, or what did I start with? Snorlaxy, to make that full conversion. Okay? So in a math class, they'd say, well, we end up losing the fraction, we just have the 2. Okay? In a chemistry class, we tend to carry those, okay, because we're not measuring a solid physical object, we're looking at distances or times. We can have fractions of a second. We can have fractions of a distance. We can have fractions of a volume. They aren't a physical solid object. Does that make sense?
Yes.
So the meaning behind the unit comes later. And that's where we have to manipulate.
And
Okay.
is something like this going to be on the test?
So could something like this be on the test? Did anybody see the practice exam?
Yeah, it's right there.
And it's right in the practice exam. Yep, absolutely, you could show up. Okay. What I would be putting there, okay, is the full decimal value. I don't expect you to do this extra manipulation because What the hell is a skittle fart?
It's a gas.
If you don't know what that is, you can't make that next logical leap. You have to provide the full decimal. Did I create that question? Yeah. If we're really going to go through this, I'm pretty sure the origin behind this was that I was watching TV while I was trying to come up with some question because people kept associating meaning with their units and not solving the question. Just saying, well, I know how to do this. Okay? So I created new units. And the commercial happened to be for Skittles. Taste the rainbow. And for whatever reason, I don't know, maybe I farted at the same time. It was like a rainbow fart. There it is. Okay, Skittle farts. Okay? Maybe I was watching Pokemon. I don't know. Maybe that was during that process. And Snorlax is a Pokemon, right? And I was like, well, but it's multiple, so it's got to be plural. Snorlaxes just sounds weird. I'm going to make it Snorlaxy because that's cooler. There's the origin of those terms.
So essentially what you're saying is this question is based on how you think.
Yeah.
That's
Yeah.
scary.
So again, think back to what we've said on multiple occasions. Where should you think? Outside of your head. Because the instant you do it in your head, you come up with weird skittle fart things. Put it on paper so everybody can laugh at you.
Please.
Again with my failures.
You don't get an I plural unless you have the US.
But with Pokemon you do. It's a special case. Any case, we have a video or a little internet meme here. If you've seen these kind of things, we got the country balls talking to each other. We've got, those of you who don't know, the US flag country ball and the French country ball. Have a little conversation. Okay. US sees the tank. Ooh, that's a cool tank. I'd like to make some money. I will build said tank for you. You just give me all the plans. Oh yeah, heck yeah. Here you go, US. Build me a tank. Right? US looks at 5,000 inches long. That's a really big tank. No. Not inches. Millimeters. What? I don't even understand that. Do you have this already converted across? No. Oh, well then never mind. I don't need to make the money. You can have your tank. Literally happened. Okay? We like a tank, but it's made by somebody else with a different unit system. I don't want to have to retool all of my equipment just to match your stuff.
Yeah.
I walk away. Literally, this is what's happening within our English metric system for conversions. And we end up with all sorts of bizarre systems where you get sig fig and unit drift, okay, which we saw in that previous question. Okay. Compound units are another way to look at conversion factors. Okay. It's just putting two units into the same conversion. We did this. Okay. Snorlaxy to pennies or dimes, whatever it was. Okay. Meters to yards. Those were compound units. Have you used compound units before?
I'm sure.
Yeah. What is the speed for your car, bike? Miles per hour. That would be
Not my plane.
not your plane.
It goes in RPMs.
Oh, yeah. Miles per hour. That is a compound unit. That allows you to convert between a distance, miles, and time, hours. Right? So if we had a motorcycle traveling at 105 kilometers per hour, what is the speed in meters per second? Okay.
Well, you have to change.
I don't think it's that bad, actually, as the speed.
Hours to seconds.
Okay. If we go through and look, what do we want for an answer?
Meters over seconds.
Meters over seconds. Note that when I write this, I'm not writing meters per second. I'm also not writing meters / seconds. What's in the denominator if I wrote meters / seconds?
Nothing.
Seconds is in the denominator. And you all got it wrong. It's seconds is in the denominator when we write meters / seconds. This is the same thing as this. But it doesn't look like it, so everybody jacks up the interpretation of this. So as soon as you see that per, set it up in the numerator-denominator fashion. You don't have to worry about it. Okay? What are we given to start with? We have Kilometers per hour. What is the number associated with that? 105. What is the 105 closest to? Kilometers. Where should the 105 get written into my fraction? Next to the kilometers. What is the number next to hours? 1. Why does it have to be 1? If it's not 1, is that 105 kilometers per hour? No. Any other number than 1 changes the meaning of the 105. We can't change the meaning because that was given to us. Okay? Is kilometers per hour the same thing as meters per second? No. So what do we need to do?
Put it over.
Conversion factor, right?
Put it over again. Make it bigger.
Okay. Kilometers per hour, meters per second. Wow, what do I do?
Put it over seconds conversion.
Okay. So I'm hearing seconds. I put it over seconds.
No, do a second conversion underneath.
Do 2 different conversions. Multiplication, division, the order doesn't matter. Pick one of your units you want to convert, stick to that one. In this case, I'm saying seconds. I want seconds. Problem with picking seconds? Can I go to hours? No, I end up with that weird, goofy order that at least some of you are like, that's an awful order. I don't want to do that. So let's not do that. Okay? I heard somebody say hours and minutes. Okay? What are you focusing on when you're saying hours and minutes? What are you trying to do in your solve? Get the hours, just the time unit, the one in the denominator, closest to the time unit in the denominator at the other end. So where should hours show up in my conversion factor? Not you, Sean. Where? Why should I put it in the numerator? But when I canceled before, I had it in the denominator. Why does it have to go in the numerator now? Okay? It's not always put things in the denominator or the numerator. You're putting it in such a way that it cancels with whatever you're trying to cancel. Hours currently is in the denominator. To get it to cancel, it needs to show up in the numerator. What do I convert those hours to? Okay. I heard minutes. Is minutes the same thing as seconds? No. Why'd you pick minutes and not seconds?
Because we're progressing down a unit length.
We're going down a rabbit hole.
It's even easier than that.
Because we don't.
We don't know how many seconds are in 1 hour. If you don't know that answer, then don't write it down. Convert to something else. Do you know the conversion between hours and minutes?
Yeah, 60.
What is that conversion? 60?
No, 60 minutes, not hours.
Numbers are useless. Associate the unit to it. It is 60 minutes is 1 hour. Okay? Is minutes what I want?
No.
What do I want? What do I need to do? Minutes on the top. Why in the top? So it cancels. What do I want to convert to? Seconds. Do I know a conversion between minutes and seconds?
Yeah, 60.
60 seconds is 1 minute. Thank you. Okay. Tie the unit to your numbers. Okay. It will help minimize mistakes. Okay. Particularly at this stage, because you're just like, oh, it's just that number. Yes, you know it, but if you write it down wrong, the odds that you remember to fix your write down wrong when you go through to enter it into the calculator go to 0. Guess what jerk-off went through and tested putting 60 in the numerator? So that when you screw that up and enter it into your calculator, oh my God, it matches one of my answers, it must be right. No, the test was built properly to make sure that you follow your correct unit forms. Right? Follow your unit forms. Would I have my answer? Would I have my answer? No. What do I want? I want meters. Where should the meters show up? In the denominator. How do I, or that's not a denominator, in the numerator. How do I know I want meters to show up in the numerator?
It's in the numerator right there.
Because it's right there in the numerator on the other side. That's exactly why. What do I want to show up in the denominator? Ooh. Okay. Seconds is already there. I don't want seconds showing up in my numerator. Fudge, denominator. I want meters to cancel the last unit. What's my last unit? Well, it's not minutes, because I've been doing a good job writing out my units. I've crossed out the ones I've already gotten rid of. The only one left is kilometers. What is the conversion factor now between meters and kilometers? What does killi mean, or kilo? 10 to the power of 3. Where does the power of 10 show up? With the core unit, which happens to be on top. And now it runs together as one long line. Now I just have to enter it into the calculator. This is 1, 2, 3 conversions. If you don't want to do it this way and want to break each of those conversions down into steps, you are more than welcome to do so right now as practice. Okay? And by right now, I mean up to the exam, okay? And even including the exam. The issue with that method is that when we switch to other units where you have to string 6, 7 conversions together, you're now going to be increasing the odds of making a mistake at each of those intervals. Okay? With one equation to solve, it can simplify and prevent you from making those mistakes. If you do not make those mistakes, there's nothing I'm going to complain about because your work is perfect. Okay? And your answer is perfect. Sort of. I will probably still complain because that's what I do. Okay? But I can't take off any points. Okay? This minimizes those chances for mistakes and allows you to get it done faster. Okay? You have time. Do whatever way works for you. Right now, what you should be doing is testing all ways to make sure you know and are consistent within an individual process that you can use for future questions.
Do you have to write it as a power of 10, or can you write it?
You do not have to write it as a power of 10. You can multiply it out. But if you're multiplying it out, how did you multiply it out?
You have to show your work for it.
Nope. 10 to the third is what? 1,000. Nobody pulled out a calculator. Where did you do that conversion? In your dangerous, scary, freaky brain. Okay? If you put it on the calculator with enough practice with the calculator, you can remove that brain screw up, because the brain will screw you up. Okay?
So in other
You
words,
are
it's
your
safer
worst
to
enemy.
do it that
It is
way.
safer to do it this way. Hi. If you learn anything by the end of this course, it should be that your brain is scary. Right? Do we need to go through the other conversions? Not today. There's an answer, so we'll just skip that. Percents, are we okay with the percents? All this is a copy from the old slide. Yes.
That one's easy.
Volumes.
I don't know.
Right? Volumes have multiple different units that we can use. We can use a standard volume measurement, or the accepted one, liters, okay, which we can vary through the metric system, milliliters, centiliters, all that fun stuff. Okay? But where did that measurement come from? Well, that measurement came from distance. Because when we calculate the volume of a cube, it's length times width times height. It doesn't say liters. It's length times width times height. So how did we establish what a volume was? Okay, well, we went through and said, if I had a cube that measured 10 centimeters on each side, that I am now going to define as 1 liter. That's it. That's what they went through and did. So that if we go through and look at our length unit for a volume, it is now merely a length, centimeters, times centimeters, times centimeters, also known as centimeters cubed. Because we're looking at the volume of a cube. When I now change to a different sized object, I can now use other processes to determine that volume. I don't have to go through and measure those lengths. Right? That's the whole point behind this. Okay? The issue with this system is that we now have 3 units showing up, or 3 conversion factors. Okay? And where this becomes tricky is that if I want to convert between a distance measurement of volume and a non-distance measurement of volume, say like liters. Okay? An automobile engine displaces a volume of 498 centimeters cubed in each cylinder. What is the displacement of a cylinder in cubic inches? Okay, well, how do we set it up? Inches cubed is what we want as an answer. Okay, so if you don't know how to do the conversion, this gets written down. You're acknowledging that you know what you're trying to get to. Okay? What else should get written down? Centimeters cubed with the number 498. If this is a question on the show your work, what have you just shown? Some work. I heard someone say, I have no idea how to solve this question. That gives you 0 points. That gives you maybe a pity point. Okay? You've at least shown that you can read the question and write something down. Okay? And you wrote it down in the proper locations. That deserves some credit. Okay? So now the question becomes, how do we do this conversion? Well, do you know an inch to centimeter conversion? Okay.
Wasn't there a given at the very beginning?
For this one, I didn't give it to you yet. But
2.54.
if we flip to the beginning of the exam, might be what you're asking. 2.54 centimeters
For 1 inch.
is 1 inch.
Wouldn't that be different between, because of the cube?
Cool. You're right. I didn't place those in the wrong spot. This is why we write down our units first. See, even my brain. We already knew my brain was a scary place. Centimeters and inches. 2.54 centimeters was 1 inch.
Don't you
Cool.
need the cubed in the
Oh,
corners?
you're right. It says cubed. Okay, so I'm just going to cubed.
We have to calculate that.
What do you mean you have to calculate
It's
that?
the same amount because we're still dealing with length.
And it's an exact conversion.
Wouldn't that change that?
Because 2.54 is,
You're right. I do need to cube centimeters, and I do need to cube inches. When I'm cubing this, am I cubing just the centimeter? What am I cubing? The entire thing in front.
Yes.
The conversion is not 498 divided by 2.54. The conversion is 498 divided by 2.54 cubed. Very subtle change in where we place the cubed and how we identify it, and our answer goes completely different. And to reiterate, guaranteed one of your multiple choice answers is 498 divided by 2.54. Okay? And that is the wrong answer. Okay? Cubing is a great thing if you can acknowledge when and how to use it correctly. Let's say you don't. Okay? Just for giggles. Because giggles are always fun, right?
Goldfish.
Yeah, they're packaged in every goldfish. Okay. If we go through and did just this conversion, okay, what would we get as an answer? Just give me the units. I would get centimeters cubed times inches. I'm showing a little bit more work for those people that missed. Divided by centimeters, right? Everybody see that? We're just grouping all the units. Okay. Centimeters shows up in both the numerator and the denominator, so what can you do?
I can't think of how.
Can I cancel them entirely? No. I can only cancel one, and my unit becomes centimeters squared times inches. Is that the same thing as inches cubed? No. If you track your conversion carefully, you can account for these kind of simple mistakes. Okay? If you don't want to go through and use the shortcut of the cubed, is there another way to do this?
Multiply it out.
Serena in back, I think, was talking about it. I can convert one of those centimeters cubed into inches. I can convert another one into inches. I can convert the last one into inches. Now what happens? That becomes 2. That becomes 1. Running out of colors. And that becomes 0. What is centimeters to the 0 power? 1. And the unit disappears. Right? What is an inch times an inch? Inch squared. Inch squared times an inch. Inch cubed. Make sense? We good? Okay. So for those of you looking for an answer, you go through and enter that into the calculator. The calculator will magically spit out, because I think I'm doing this right. Because I said it was inches cubed, I can just write inches cubed. More than likely, this is not an answer written in your show your work, or sorry, written in the multiple choice. What is wrong with this answer?
Sig figs.
Sig figs. How many sig figs am I allowed in my answer?
3.
1, 2, 3. My correct answer is 30.4 inches cubed. This one's correct. This one is wrong. Make sense?
I'm just going to write the letters. Watch this.
Okay. Yeah, absolutely. Right, we showed multiple ways to do it. The only way that you don't receive credit or full credit for this conversion is this one. Every other conversion is valid. This one does not receive credit. I don't know what that cubed is meaning. Add parentheses, you get credit. Do it 3 times, I'm not going to write it again, you get credit. Okay, make sense? Okay. What if you have an irregularly shaped object?
What? No.
Okay, star or a crown. Okay, what am I trying to represent with that last one? I know what I need to do for the, I know how to adjust that one now.
Red Bull?
Let's see if I can adjust this, see if it makes sense.
Is that the original shape of a Red Bull? Red Bull give you wings. Literally?
Skittles.
No. It's a Skittle fart. How do I measure the volume of a Skittle fart?
Well, it was 8 pounds.
Okay? It's a gas. What is that gas going to do? It's going to expand all over the place. That makes it difficult to measure its volume. So I want to be able to come up with some way to trap it. Okay? Same deal with the other objects. Okay? We can pull out mathematics for that first shape and say triangles and circles and ovals and all that fun nonsense, and that would suck mathematically. Okay? Scientists came along and said, I don't want to do all that mathematics. How else can we determine the volume of those objects? You can stick it in water, which you've done already in lab. Okay? You can measure volume by displacement. Okay? This was Archimedes, I think. The whole Eureka. That is this. He was challenged to finding out if a crown was made of gold. So what did he do? He said, I have no idea how to do it. I can figure out the math, but that's about it. And then he sat down in the tub because he was trying to get a little steam to think about, come up with ways. And he saw the water rise. He goes, oh, Eureka! I now know how to measure the volume. Because I know the volume and the mass, I can determine the density. Gold has a particular density. I can now determine whether the crown is made of gold or something else. Because I can compare it back to a standard that I know is gold.
Just scratch it.
Okay? Scratching it does not work. Not as an absolute. Okay? So, if we went through and looked at gas by displacement, okay, we can do the same thing with gases, but we have to trap the gas somehow. That's what's happening in this. We're saying there's a reaction. Here, the flame causes that reaction to occur, and a gas is formed. Where does that gas go? Well, it pushes down into the tube, but then pressure builds up inside here. What does that then do?
Forces the water out.
Pushes down on the water, which forces the liquid or the water out of the tube to collect over here. I can then measure the difference in distance there to determine the volume of the gas produced. Kind of neat. There's a big problem with this. Have you ever taken a balloon and put it near a fireplace? Before it explodes, what does it do? It starts to expand. Why is it expanding? The molecules move faster, causing the gas to expand. Okay? Temperature has an effect on our volume for a gas. If I have the flame here, what is also happening to those particles? They're getting hotter, which means, am I measuring just the production of the gas? No, I'm measuring the production of the gas and the heat. How can I minimize that heat? Put the fire part of the experiment really far away from the measurement part of the experiment. Simplifies it. Now, by the time the gas makes it over there, there's no heat associated with it. The only thing causing the water to change, in theory, is now the volume of the gas. Okay? Just something to consider when you look at that. I want to look at density because we got a little bit of time and we can get through it. What weighs more, a pound of lead or a pound of feathers?
They weigh the same.
They're the same, and it's always fun to make fun of little kids for that. Okay? Oh, the pound of lead weighs more. Which would you rather get hit by? Okay? You probably want the pound of feathers. Okay? All sorts of psychological reasons go into that, but one of the reasons why we tend to say the pound of lead weighs more is our concept of density. Okay? And I don't know what you guys put down for your lab when you were doing the density lab, but I noticed that my students kept saying that they would determine gold by measuring its mass. And if it was heavy, it had to be gold. Well, that's true. I got some bricks I can sell you at the price of gold, because those are really heavy bricks. Okay? It's not mass, it's density. It's the relationship between the mass and the volume. Okay? That is our density system. What have we now established, particularly if we write down the unit for mass? What is our unit for mass? Grams. Our unit for volume? I'll accept either liters or milliliters. Liters is the correct unit if we're going to talk about our core unit. Okay. What do we now have? A conversion factor. Density is a fancy way of just doing another conversion. That's it. Okay. With that, I'll kind of leave you at it. We'll run into different units for density. Not a big deal. We'll talk. What is today?
The 2nd of October.
It's really only Monday. Okay, we'll start Wednesday looking at liquids, comparing densities and what that means, and then we'll continue to move on. I may shuffle slides around so that we can get to reactions. We're just a little bit behind.